Trying to see low exposure images using CNN. Abstract. Due to low photon count ratio, imaging is very difficult in low light. In long exposure images there is a blur, and in short exposure image there is noise present. There are various types of techniques given, like image enhancement, denoising, deblurring, but they are limited in difficult conditions. Considering the new developments in learning-based pipeline in low-light image processing, we have selected a dataset of raw short-exposure low-light images along the side which there are reference of long-exposure images. Based on fully convolutional network with end-to-end training and with the dataset selected, a pipeline for low-light images processing is developed. This pipeline network processes on raw sensor data and improves the old image processing pipeline, which does not give good results on the data presented. Our result is genuine on new dataset presented. Keywords: CNN, short exposure, contrast enhancement, resolution. Introduction. Short exposure images are the images of moving objects, which often introduces noise, blur, and the image therefore is not clear. If the brightness of the images are to be increased, it introduces noise. In case of fast imaging in low light in photography is a challenge. Various techniques have been introduced by various researchers, like enhancement of low-light images, deblurring, denoising. But in these techniques there are certain conditions, like image need to be captured in dim environments with noise level moderate. But we are interested in short exposure and extreme low-light imaging. 2. Related work. Many researches have been done on different methods for long exposure image to short exposure images, image denoising, and enhancement of low light imaging. Here some prominent works done in the field are discussed. A low light image enhancement. In one for low light image enhancement they have used a Retinex model. In the model the observed low light image is represented as pixel-wise multiplication between enhanced image recovered from observed low light image and illumination map. The method works as follows. The model first estimates the illumination map, and based on element-wise division between observed low-light image and illumination map. To estimate each element in illumination map, max RGB technique is used. After max RGB estimation, the image is processed for texture removal, then edge recovery through guided filter, then passed through simplified Retinex model to acquire enhanced image. Various techniques have been applied to improve the contrast of low-light images. The most common is histogram equalization. It balances the histogram of entire image. Another widely used techniques is gamma correction, where the brightness of dark regions is increased by compressing bright pixels. The advanced methods like inverse dark channel prior, the wavelet transform, the Retinex model, and illumination map estimation. But there is a drawback, that these methods assume that the images are already containing good representation of image content. The method for image denoising is not explicit or different, and apply the general denoising technique in the post-process. Therefore we consider extreme low-light imaging in which color distortion and noise is present, which is very difficult to operate in existing enhancement pipeline. B. Image dehazing. Haze is natural phenomenon where the visibility of the sky is altered or disturbed by dust, smoke, and other particles. Hazy images causes different visibility issues for tourists, traffic users, and in hilly regions where the haze and fog are very common. In 6 method for single image dehazing using convolutional neural network is used. The images used are outdoor, on which particular filters are applied to find haze in image. The images which are hazy contain a small value in only one color alpha channel from red, green, blue RGB channel. The pixel intensity is mainly represented by air light depth map. By estimating these low value points of haze transmission map, it is useful to obtain high quality dehazed image. To achieve a high quality dehazed image, an end-to-end encoder-decoder training model is used. Equalization function is known, then the original histogram can be recovered. The calculation in this method is not computationally difficult, but there is an disadvantage. While decreasing the usable signal, it may increase background noise. Histogram equalization is suitable for scientific images like the X-ray, satellite, thermal images, but it produces unrealistic effects in images. It can also introduce undesirable effects if applied to images with low color depth. See contrast enhancement. Contrast enhancement, CE, refers to the image enhancement on contrast by adjusting the dynamic range of pixel intensity distribution. 1. CE plays an important role in the improvement of visual quality for computer vision, pattern recognition, and digital image processing. In real applications, we usually encounter digital images with poor contrast or abnormal brightness, which may result from different factors, such as the inexperience of taking photographs and the inherent deficiency of imaging devices. The capturing scenes with low or high illuminance intensity may also lead to reduced contrast quality. Despite of visual quality degradation, low contrast might hinder the further applications of a digital image, including image analysis and understanding, object recognition, and digital printing, etc. As such, it is essential to enhance the contrast of such distorted images before further applications. 3. Methodology. A low-light image enhancement using CNN. We used an end-to-end trainable network so that the images captured in low light will be converted to proper exposed images. We have selected C in the dark, SID, dataset which consist of raw short exposure images paired with long exposure images. A. Bayer array. B. Network architecture. B. Contrast enhancement. Contrast is an important element in evaluation of image quality. Contrast is nothing but the difference between luminance of two adjacent surfaces. In simple words, contrast is a property which helps an object stand out from other objects and its background. To determine the contrast, find the difference in color and brightness of the required object with another objects. Contrast enhancement of images whose brightness is distorted which have global intensity relatively high or low is applied. C. Increasing resolution. We have used deep CNN with residual net and skip connection, where skip connection in an architecture of neural network skips some layer and the output of the previous layer as passed on to input of the layer after skipped. The feature extraction network is nothing but combination of deep CNN and skip connections. For image reconstruction network parallelized 1*1 CNN which is called network in network. 4 results. A low-light image enhancement using CNN. Above is the comparison between the image produced by convolutional neural network. The qualitative analysis is of the image produced by CNN compared to ground truth is given is table below. We have tried to denoise the given output that got by CNN to remove the Gaussian noise from the output to improve the quality of the image, and we also succeeded in doing so clear from the below table which measures PSNR and MISM compared to the long exposure ground truth from given dataset. V. Conclusion. 1. Zhuangfeng, Shijihu low-light image enhancement by refining illumination map with self-guided filtering. 2. H. C. Berger, C. J. Schuler, and S. Harmeling. Image denoising, can plane neural networks compete with BM3D? In CVPR, 2012. 3. Junyuan Xie, Lin Lisu and Hong Chen. Image denoising and in painting with deep neural networks. 4. Chen Chen, Kifeng Chen, Min N. Du and V. Ladelan Colton. Learning to See in the Dark. CVPR 2018. 5. J. Anaya and A. Barbu. Renoir, a dataset for real low-light image noise reduction. AR 141409.8230 2014. 6. Huzaifar Rashid single image dehazing using CNN. In Elsevier. A deep learning network to solve the problem of low-light imaging achieve results better than traditional and recent denoising pipelines. We tried an array of various components as part of their network, but UNet outperforms every single one.